Let's take a look at the following multi-step equation. Let's see, we have 2 times 4x minus 3 minus 9 times 3x plus 2 equals 7. Okay. Here we have a couple different expressions on the left side with variables inside the parentheses. So we can go ahead and just distribute these at the same time. It'll save us a little time and a little space. We want to make sure we're watching our signs and we don't miss anything. So we're going to distribute these into the correct expressions. So we have 2 times 4x, which is 8x. We have 2 times minus 3, which is a minus 6. Now we have a minus 9 times 3x is a minus 27x. A minus 9 times a positive 2 is a minus 18 equals 7. Okay, there's nothing wrong with using the distributive property twice in the same step as long as we're careful with it. All right, now we can combine a few like terms. We have an 8x here, a minus 27x here, we have a minus 6 here, and a minus 18 here. So we can also do that in one step. 8x minus 27x, the negative wins out, so it's a minus 19x. Minus 6x, or just a minus 6 and a minus 18 is a minus 24 equals 7 on the other side. Now now that we've got it down to one variable in one place and it's not buried inside any fraction bars or parentheses, we can begin to extract it and isolate it by moving everything else to the right. So let's start off by adding 24 to both sides. Plus 24 minus and a positive 24 cancel out, which leaves us a minus 19x equals 7 plus 24 is 31. And we have one more step. We have the variable being multiplied by a whole number, so we simply divide by the coefficient. Now notice we're dividing by a negative 19 here because we want to solve for a positive x, so we want the negative signs to cancel as well as the coefficients. So be sure that if we have a negative coefficient in front of the variable, that we're multiplying by the negative coefficient, so we get a positive x and not a negative x. This is going to leave an x on the left and a minus 31 over 19 on the right. And that's our answer. And again, we can always check this by plugging in minus 31 over 19 wherever we see x into our original equation, and it should hold true. Okay, we should never get an equation wrong because we can always take a few moments just to check it afterwards. All right, let's move on to the next example. We have a 2 over 3 times the expression 5 over 8 plus y plus 1 over 4 times 5 minus 2y divided by 7, and this equals 3 times 1 minus y. Okay, this is just a mess. We have variables buried inside fractions, buried inside parentheses, and on both sides of the equation. But don't get excited here. We do know how to do this. We know how to deal with this, so let's just take it one step at a time. And we have 3 terms that we need to distribute into 3 separate expressions. Up here we did 2 in one step, so it's not a far reach to do 3 in one step. Let's just make sure that we're watching our signs and make sure we're distributing the correct numbers in the correct places. We can actually draw the distribution lines if it makes it easier for you. This 2/3 is going to multiply here and here. 1/4 is going to multiply here and here. And 3 is going to multiply here and here. Okay, so let's do this. We have 2/3 times 5/8, which is 10 over 24. Then we have 2/3 times a positive y, which is a 2/3 y. We have a 1/4 times 5, which is simply 5/4. We have a 1/4 times a negative 2y over 7, which is a negative 2y divided by 28. All we did is multiply numerator times numerator, denominator times denominator. That's how we get 2y over 28. And on the other side, we have 3 times 1, which is 3, and 3 times a minus y, which is a minus 3y. Okay, moving on to the next step. We can actually, I'm a big proponent in simplifying as we go, so let's take the time to simplify as we go and making our calculations a lot easier. And also while we're simplifying where we can, let's go ahead and regroup a few things together. We can group this fraction and this fraction together, and we can move this fraction with the variable and this fraction with a variable. We can put them together so they're side by side, and it just makes things look a lot simpler. Okay, so 5 over 24 can simplify. We can factor out a 2 out of the top and the bottom. So this factors into 5 over 12. Simplifies into 5 over 12. Let's move the 5 over 4 right next to it, because we're going to deal with those in a second. We have our plus 2 over 3y. And let's simplify this. We have a minus. We can factor out a 2 out of the top and the bottom, which gives us a 1 over 14. And let's go ahead and write the y out to the side. We don't want to incorporate it in the numerator, and I'll show you why in a second. And we're left with 3 minus 3y on the right side. Okay. Next, we're going to go ahead and combine these fractions. So let's rewrite 5/4 as a fraction with the denominator of 3, or denominator of 12, excuse me. We actually multiply by 3 to get 12, so let's do the same on the top. So let's rewrite this. We have a 5 over 12, and this is going to be turned into a 15 over 12. We can add it in the next step more simply. Now for these two fractions, instead of finding a common denominator, let's go ahead and combine these two out to the side. Let's do this over here, out to the side. Drop the variables and just deal with the coefficients. We have 2/3 minus 1 over 14. Okay, let's do some little cross multiplication just to make things pretty easy. We got 2 times 14 is 28. We're subtracting these fractions. 3 times 1 is 3, and 3 times 14 for our denominator is 42. And that gives us 28 minus 3 is 25 over 42. Okay, this is out to the side. This isn't part of the problem, it's just out to the side. All right, so we have a positive 25 over 42, and let's not forget our variable y. So all we did right here is combine these two fractions right here. All right, and we still have our 3 minus 3y out to the right. All right, moving right along. Let's go ahead and combine these two fractions. 5 plus 15 is 20 over 12. And we have our plus 25 over 42y. And so all we did is we combined these. Let's go ahead and, since we're moving our variables to the left and we want everything else to the right, let's go ahead and move our minus 3y over to the right. So let's go ahead and add 3y to both sides. Plus 3y. So we can cancel this out. We can add it to our left side. And we'll just be left with 3 on the right side. Okay. Again, we want to simplify as we go. We can simplify this 20 over 12 into, we can factor out a 4 out of the top and the bottom. That'll give us 5 over 3. Rewrite our 25 over 42 times y. And let's go ahead and rewrite 3y with the denominator of 42, because we're going to add these in the next step. So we can change 3y into 126 over 42y. 126 over 42 is the same thing as 3. Okay? And then we have our 3 out to the side. All right, moving right along. Let's go ahead and we're moving all the variables are on the left, and we're moving all the rest of the junk to the right. So let's go ahead and subtract 5 over 3 from both sides. 5 over 3. That means those will cancel. And let's combine these in the same step. 25 plus 126 is 151 over 42y. And that's it on the left side. On the right side, we have 3 minus 5 over 3. Let's go ahead and turn 3 into a rational number with a denominator of 3 so we can subtract these. 3 is the same thing as 9/3. 9/3 is equivalent to 3. And we have our minus 5/3. Let's rewrite our 151 over 42. We don't want to mess with that yet. We want to save that for last. And let's subtract this. 9 minus 5 is 4, divided by 3. And we have one step left. To isolate our y from our rational number, we simply multiply by the reciprocal. The reciprocal of 151 over 42 is 42 over 151 times 151 over 42y. We have, on the other side, 4/3. We're multiplying by the same reciprocal. We're doing the same thing on the other side. 42 over 151. This fraction cancels with this fraction. We're left with just y on the left side. Now over here, let's go ahead and simplify this as we go. We can factor out a 3 out of those two terms, which leaves us with 1 and 14. 1 and 14. 3 goes into 42 14 times. That's right. And now we can simply, our calculations are a little easier now, so we can simply multiply numerator times numerator, denominator times denominator. 4 times 14 is 56, and 1 times 151 is 151. And there you go. Okay, that took quite a few steps. That's why we call them multi-step equations. But I just want to get you in the habit of not getting too excited whenever you see a big problem like this with lots and lots of steps. As long as we take it one step at a time, we know how to deal with this, and I'm confident that we can handle something like this in the future. We just want to make sure that we watch our signs and we take it slowly one step at a time so we don't make any mistakes. And like always, we can plug this back into our original equation. Everywhere we see y, we can plug in 56 over 151, and we should get an equivalent answer. And this one is indeed the valid solution. So I'll leave that for you to check, and I'll see you in the next video.